Assalamu alaikum to you all. As explained in the introduction lecture, in this course we are going to study many different data structures. We're going to study not only the data structures but also their implementation. Because it is only when you know how to implement a data structure that you can really be able to understand how efficient it is. Okay, of course we are learning these different data structures not just for learning's sake, but because we want to be able to decide if we are confronted with a project in our programming career, which data structure to use for that particular problem. So this is why we are learning many different data structures so that we can be able to choose the right one for the right project. Now, of course, when I say comparison between the two data structures, our focus is usually two important points. The efficiency of the data structures with respect to their speed, or what is called time, which one will run faster than the other. And the other aspect is space or memory, which data structure will economize the use of memory compared to the other. So these are two important points that we must be able to do when we compare two data structures. So in this lecture we are going to study the first one, which is singly linked list. Now when I say first one, I mean in this course. I am aware, of course, that you have already learned arrays in programming 1. So we're going to assume that, and we're going to build on that to study the next one, which is singly linked list. Okay, so this is the outline of the lecture. First, we will take a little motivation. Why do we want to study about singly linked list? And then explain what it is. What is singly linked list? And then we go deep into implementation of singly linked list. How do we implement singly linked list? When I say implement, I mean how do we implement the operations of singly linked list, like insertion, adding an element to singly linked list, or deleting an element from a singly linked list, searching, how do we search for an element in a singly linked list, and many other operations. This is basically the objective of this lecture. Now, in terms of motivation, the point is we already have a data structure we know, which is array, which in fact is very efficient in terms of time. As you know, array gives you direct access to its element. Yani if you have an array of size, let's say 1000 element, and you are trying to locate element number 900, all you have to do is give the index, and the system will take you directly to that element number 900. So this is one of the great advantage of array that in fact no other data structure has. It gives you direct access to its element, and therefore you cannot beat it in terms of speed. But array has problems. In spite of this advantage in terms of giving access to its element directly, it has a problem. It has two main problems. One problem relates to its size. As you know, when you try to create an array, you have to give a size. And unfortunately, when you give that size, that is it. You cannot reduce the size, and you cannot increase it. Now the problem is if the size you give is too big relative to the data that you wish to store, then you are wasting memory. On the other hand, if the size is too small, you discover this after the program is already running, then you are in trouble because you cannot increase the size of an array. Now there's a way around this problem, but that is also not for free, which is that you can, if you realize the array is too small, you can create a bigger size. Okay, you cannot increase the size of the original one that you created, but you can create a new bigger one and then copy the data from the old small one to the new big one, and then continue your insertion from the the rest of the elements. You can do the other way around. If the array is you realize is too big, the one you created is too big compared to the data. Again, we said you cannot decrease it, but you can actually create a smaller one and then copy the data from the old one to the smaller one. This, in fact, is what array list, which I'm sure you are familiar with from your programming tool. This is what array list does. We call it flexible array because the Java system takes care of the size. You just create an array list. Java will give a default size. When the array gets exhausted, the Java system will create a new bigger one and then copy the data from the old smaller one to the new bigger one. But that is not for free. This is one of the problems. It says here, changing the size of the array requires creating a new array and copying all the data from the old array to the new one. The problem with this is there is a waste of time. Remember, we said our two principal points when trying to assess the efficiency of a data structure is time and speed. So there is a waste of time here. The time needed to copy the data from the old to the new is going to be wasted, and it may make your program slower. So this is one of the problems with array. The second problem with array is that it is what is called contiguous, meaning the elements of an array are arranged sequentially in the memory. Okay, next to the cell containing U here, for example, is the cell containing B, and so on like that. The problem with this is if you wish to insert a new element in between, then this is not possible, at least not for free. What you will have to do is you have to shift all the other elements that are already in the array to the right to create a room for you to do an insertion. So this is another area where array has a problem. Okay, so it says here, the data in the array are next to each other sequentially in memory, which means inserting an item inside the array requires shifting some other data elements that already exist in the array. So these are the two principal issues with array, and these are the motivations why we want to learn about linked lists, because these limitations can be overcome by linked list. Okay, so this is the idea why we want to study about singly linked list. So the next thing is, what is singly linked list? Now, to define singly linked list, maybe we should start by defining what is linked list, or maybe what is link structure. This is in fact how our book does it. It starts by defining the term link structure. So what is a link structure? Link structure is a collection of nodes storing data and links to other nodes. Okay, so you have a collection of nodes. Each node will have a data item and a link or links to other nodes. Now notice here there is no restriction in terms of the ordering of the elements, or in terms of which node will link to another one. So this is very much general, as I would like to show you here in this diagram. So all of these diagrams you are seeing are example of link structure. Okay, the only thing in that definition is that we have a node, and that node has some data and links to other nodes. Okay, a node with some data and links to other nodes, and so on. There is no restriction on how we make the links. Okay, so this is the idea of link structure. We're going to study all this type of link structure in this course. This actually is an example of a graph, which we shall study towards the end of the course. This is an example of what is called a tree. So this we will study towards the middle of the course. This is an example of doubly linked list. So this is a linked list, but it's not a singly linked list. It is a doubly linked list, because as you can see, each node, in addition to the data, it has reference to the next element and also a reference to the previous element. Okay, so all these are examples of link structures. The next item is linked list. What is a linked list? So linked list is a data structure composed of a list of nodes, each node holding some information or data and reference or references to other node in the list. Now the key difference here between a link structure and a linked list is the keyword here, list. When we say list, necessarily it is one dimension. So one dimensional, yani. So if you compare with the figure I showed you here, obviously this is not a linked list. Okay, and similarly here, because it's not one dimension. But both of these two, okay, are example of linked lists. So both of these are linked lists, one dimension. Okay, you cannot have multi-dimension as we have in the case of graph and trees. Okay, so that's linked list. And the last one, which is our target, is singly linked list. What is a singly linked list? It is a linked list in which each node has only one link. Okay, it has a data and one link, and that link is only to the succeeding node or to the successor node. There is no link to the previous node. Okay, so this is the first type of linked list that we are going to study. After this, of course, we're going to study the doubly linked list. So again, coming back to our diagram here, this is what we are concerned with. Okay, so if you can observe, there is a big rectangle here, blue, telling you all these are examples of link structure. Everything inside this blue rectangle is a link structure, but only the figures inside this purple rectangle are linked lists. Okay, so doubly linked list is a linked list, of course, but singly linked list is even more narrower. Okay, so that's basically the idea. It starts from a more general definition to the narrowest definition. So this is the simplest data structure and that is what we are going to study. Each node in the linked list has just two things: information or data, and a link to the next node. Okay, right, so that's what is a singly linked list. Now let us see how we can implement it. Now the first step to implement a singly linked list is to actually write a class to represent its node. So we need a class to represent a node of a linked list. Now if you notice, the node of a linked list, they have two variables. As we said, each node will have information and link to another node. Therefore, when we define a class to represent a node, here we are calling it SLL node, meaning singly linked list node. Okay, we need to have two variables. Now our node is going to be generic because we want our linked list to be able to store any type of data. It could be integer, it could be double, it could be student objects, any kind of data our linked list should be able to store. And therefore this info aspect of the node has to be generic. That is why we are using the angle bracket here with a type T, indicating that the type is going to be generic. It is at runtime that the user will specify what the type is. Okay, for now, this is a general definition for a node. Okay, so the two variables are info, which is of type T. So we don't really know the type yet until runtime when the user will specify the type. I'm sure you are familiar with creating a generic class from your programming 2 course. Okay, so this is the idea. So the first variable in our node is of type generic T. Okay, what about the second variable next? Now, second variable is a reference to another object. The question is, what is that object? It is another node, and therefore the type is the same as the name of this class. Okay, so as you can see here, next is of type singly linked list node. As you saw in the diagram, each node is in a singly linked list has info like integer 3 and a reference to another node. So the type of this reference has to be type singly linked list node. This is the idea. Okay, so those are our two variables. Next is constructors. When you are defining a class, of course, you have to define constructors that will allow you to initialize the values of your variables. So this is our constructor, the main constructor, singly linked list node. It will receive two input, element of type T. Remember, T is the generic type T, and a pointer of type node. So what will the constructor do? As usual, it will simply assign these values to our variables. So info becomes element, and next becomes pointer. This is no different than what you are used to when you create, for example, a student class. You will have a constructor that will receive the ID, the name, and GPA, and the constructor will simply initialize your instance variables with the values that you receive from those parameters. All right, so this is a constructor for our node class. The question is, what if we don't have both info and next? We only have info, for example. Can we still create a node? Yes, and therefore we have another constructor here that takes only element to be assigned to the info. The next can be null for the moment. Okay, so how do we implement this constructor? Well, we have two options. You can do the initialization directly as you did in this other constructor, or you can call this constructor. I'm sure you already know how to call a constructor from another constructor simply by using the word this. If you say this and then you provide the arguments, the system will count the number of arguments. So here we are sending the element that we receive and also sending null. So two arguments we are sending. The system therefore will look and see, is there a constructor that accepts two arguments? Of course there is. This is expecting element and pointer. So it means this is the one we are actually calling. Sending element to element, and then this constructor will help us assign the element to info, and sending null to pointer, and then the constructor will help us assign the null to the next. Okay, so this is another way of doing it. The final constructor is if you don't have any input from the user. Can you still create a node? Yes, of course you can. Okay, and here we just need to initialize both the info and next to null. Okay, so again we are calling the last constructor here, sending it null null. So it will help us initialize info to be null and also next to be null. Okay, so these are the constructors we have in this class, and in fact these are the only things we need for our node class. In other words, there are no methods for the node class. Okay, yeah. Now the question is it possible to create a singly linked list such as the one we saw in previous figures using only this singly linked list node class? The answer is, of course, yes, it is possible. Yeah, so for example, if you look at the figure 3.1, let me take you back to figure 3.1. This is figure 3.1. It is a singly linked list containing 3 nodes. First node contains info 10 and link to another node. That other node contains info 8 and link to another node. And then that last node contains 50, but it has no link to another node. Instead, it has null. This slash here means null. Okay, and the first node is referenced by a variable called head, and the last node is referenced by a variable called tail. The question is, can we create this linked list simply by using the node class that we have just implemented? The answer is yes, we can, and this is how. These 3 statements will actually create that linked list. Now we're going to take them one by one. We're going to take the 3 statements one by one to explain how. Okay, as you can see here, the first one says singly linked list of integer. Now this is important. Remember we said the singly linked list node is a generic class. Okay, we don't specify the type until when we are ready to create an object of that class. This is the time we want to create an object of the singly linked list node class, and therefore we have to now specify the type. The type of the info that we're going to store in our node. In this case, we are saying is integer. Okay, we can decide that this is double, character, student, or any other type. Okay, but the linked list in figure 3.1 actually contains integer values, so we're going to say singly linked list node of integer. Okay, p equal to new singly linked list node of integer, and then we provide a value here 10. Now notice here the second integer here is optional. You don't have to provide it. You can just give the angle bracket. Okay, in fact NetBeans may even warn you if you provide integer like this. but it's fine. It's not an error, it's just a warning. And it's probably more clearer if you repeat the integer. Now, what does this statement does actually? This is what we are going to explain before we move on to the two other statements. It says executing each of these three statements involve at least 4 steps. Okay, as we're gonna see in this figure. Okay, now the first thing in evaluating this statement is to note that this is an assignment statement. And as we know, assignment statements are evaluated from right to left. So before we look at what is on the left, let us look at what is on the right of the assignment. Okay, on the right here it says new singly linked list node of integer 10. Okay, the first word here, new, is very important. Anytime you use new in Java, you are saying create an object of this class. In other words, give me location in the memory to store information about an object of this class. So what that will do, therefore, since we know singly linked list node has 2 variables, the system will actually create an object having 2 variables. Now, I don't show them here, but as we saw in the previous slide, the first variable here is for the info, and the second variable here is for the next. Okay, so that is simply by using the word new SLL node. Okay, you are saying create an object of SSL node. That means an object will be created, and that object will have memory location for each of the variables for that object. Okay, since singly linked list node has 2 variables, your object will have 2 variables. Good. The next thing we are doing still on this right hand side is we are supplying 10. We say SSL node and then we give 10. What do you think we are doing with that? We are actually calling a constructor. Now, if you recall, the singly linked list node has 3 constructors. Okay, one that takes nothing, one that takes only the info, and one that takes info and next. The question is, which of these 3 constructors are we calling? Obviously, we are calling the middle one here because we only provide 10. So element will be 10 in that case. So we are sending 10 to this constructor. Obviously, this constructor will send that same 10 to this constructor and null. Okay, and this constructor will now say, okay, info becomes 10, next become null. This is basically what will happen as a result of this call. So that is what we are showing in the second figure here. 10 will be assigned to the first variable here, and null will be assigned to the second variable. Okay, so this is the result of executing the right hand side of the assignment. Now, after we have done this, we are now saying send the result of this object to P, or assign the result of creating this object to P. Now, actually, new, whenever you use new, after creating the object and doing the assignment, is going to return to you the reference to that object. The address of the object that has been created will be returned. So we are now saying save that reference in a variable P. So what it means is, therefore, P will point to the new object, as you can see here. So P will point to the new object created. Okay, and that is basically what this first line will do. Okay, so as you can see, as we said there, it involves 4 steps. First, new will create the node, then the constructor will do actually both steps B and C, because it's just initialization. It will initialize the info to 10 and next to null, and then finally we will do the assignment. So the reference to the new node will be saved in the variable P. Okay, let's move to the next statement. The next statement says p.next becomes new SSL node of integer 8. What is the effect of this statement? So again, since it is an assignment statement, we're going to try to evaluate it starting from the right. As we explained in the first statement, new will actually create a new node. Okay, so this is a new node with the 2 variables again, info and next. And by putting 8 here, we are calling the middle constructor. And the middle constructor will send 8 to the info. And it will also send null to next, as you can see here. Okay, so our new object has been initialized by the constructor. Next is we're going to receive the address of that object, and we are saying save it, this time not in P, but in p.next. So that is the question, what is p.next? Okay, now you see here P is pointing to an object. It's just like you have a student object S pointing to an object. That object has name, ID, and GPA. If you say s.id, you mean the ID of the object, right? s.name means the name of the object, and s.gpa means the GPA of the object. So the same thing here, P is pointing to an object. That object has 2 variables, info and next. Okay, so this is p.info and this is p.next. Okay, so here we are saying save the address of this new object inside p.next. In other words, this reference, okay, which is presently null, actually I put null here actually, is going to change to point to the new object. So you can see p.next go to the new object or point to the new node. Okay, so this is the result of the second statement. It creates a node, initialize it, and assign its address to the next of the previous node. So p.next becomes this node. Good. Let us now try to see the result of executing the last statement. p.next becomes new node of integer 50. So again, we start from the right, create a new node. So this is a new node, singly linked list node, so the object is created. Again, here we are calling the middle constructor. So it's going to initialize the new object with 50 in the info and null in the next. Okay, we're going to receive the address of that new object, and we are saying assign the address to p.next.next. Question is, where is p.next.next? p.next.next. So this is the point we are trying to reach. We want to save the address of this object inside here. Therefore, this is actually what we have. Okay, so this reference is no longer null. Instead, it will contain the address of this node. If you watch carefully, this is exactly the singly linked list we saw in figure 3.1. So proving to you that actually the singly linked list node class itself alone can be used to create a singly linked list. But the question is this really practical? Suppose you have 100 elements. Are you going to keep repeating p.next.next.next.next 100 times? Obviously, it doesn't make sense, and it's not practical. So that's what we are saying here. Obviously, this method of creating linked lists is not practical, especially for longer lists. Although it is possible, it is not convenient. So we need a more convenient way of creating singly linked list. Therefore, the singly linked list node class that we created earlier actually is not enough. We need another class that will provide us with methods that we can easily call to add elements, to delete elements, to search for an element, and do many other operations. Okay, and that's why we need a class here we call singly linked list class. Okay, so we need another class called SLL, which will give us methods to use to initialize or to manage our singly linked list. Okay, now this class has two variables, head and tail. Both of them of type references to a node, singly linked list node. Okay, so a singly linked list class, once you create it, will have two references, head and tail. As you can see here, the constructor will initialize both to empty. This is how to create an instance of the class. You will say singly linked list. You need to specify the meaning of T when you are creating the object of the class. So suppose you say integer and you call your variable list, then you say new SLL of integer, and as you can see, the constructor doesn't expect you to give any argument, so you will just put an empty bracket here. Okay, so once you do this, what you will have is, initially, this is what you will have. You will have the two variables, head and tail, but actually both of them are null. Now here, this diagram is showing you one important convention we are going to follow throughout the course. Not only this lecture, but throughout the course. See, if we create an object of a class, normally what we have is the variables of the object are created together as a group. Okay, just like for the node, we have info and next. Therefore, when we create an object of SLL, we should have an object having head and tail as variable. Okay, the idea is head will point to the first node in our list, and tail will point to the last node in our list. Okay, of course the first node will point to the next, that will point to the next, and so on. But the idea of these two variables, head and tail, is to be able to directly access the first and the last node in the list. Okay, so although this is how we normally do it, to make it easier for us in this course, we will not put the object of singly linked list as one object like this. No, we will be doing it as shown in B here. So we separate these two variables, head and tail. In fact, we will not create any memory location for the head. We will just say head will point to the first node, and tail will point to the last node. But in your mind, you should understand this is actually what happens. There is really an object of singly linked list with the two variables, and the head will point to the first node, and the tail will point to the last node. Initially, of course, we didn't add any node, so head will point to null, and tail will point to null. Okay, I hope this is clear. But this is the objective of head and tail, to help us reach the first node directly, tail to help us reach the last node directly, And instead of drawing the list like this, we will simply draw it like this. This is more convenient. Okay, good. So this is our class. Now let's begin to implement the methods of the class. The first method we can implement very easily from the information we have here is the isEmpty method. We want to be able to know if our list is empty, meaning it doesn't have any node yet, or not. That is, it has some nodes. For example, this linked list is not empty because it has nodes. But this one is empty because it has no nodes. So we want our method to say yes if this is the case, and to say no if this is the case. How can we do that? Very simple observation. If you observe, if we don't have any node, head is null. Okay. Also tail is null. If you wish, you can use the tail. Okay. So, but if we have a node, head will not be null. It will be pointing to the first node. So a very easy way of implementing isEmpty is to check whether head is equal null and return the result of that comparison. Okay, notice here there is no need to use an if statement. You can use an if statement and say if head equal null, return true, else return false. No, you don't have to do that, because what? This is a logical expression. Head equal null is a logical expression that will return true or false. So return whatever it says. Of course, if it is this case, head equal null will return true. So return the true. If it is this case, head equal null will return false. So return the false. Okay, so we don't need an if statement. We can simply return the result of this logical expression to implement this empty method. Okay, how do we call this method? As usual, any method, you just say the object. The object is list dot method. Since it is Boolean, normally we will call it as part of an if statement, for example. So you can say if list dot is empty, do something. Okay, otherwise do something else. Okay, so this is what we have so far, is empty, but that is not the most important method for our list. Actually, we want to be able to add nodes to our list, delete nodes from the list, and so on and so forth. So in the next slide, we are going to learn how to add nodes. Okay. Now, with linked lists, you can actually add nodes to the list from anywhere. You can add node at the beginning of the list, add a node at the end of the list, or even add a node in the middle of the list. You can add a node to the list anywhere. Okay. This particular method is called add to head, and therefore, as the name suggests, is trying to add a node at the beginning of the list. Okay, so it's a public void add to head t element. So the method is going to receive info. Okay, if it is link of integer, it will receive some value like 10 or 20. You are saying add 20 to the beginning of the list, meaning create a new node containing 20 and make it to be the first node in the list. Okay, so how do we implement this method? First of all, we have to consider there are two scenarios. The first scenario is that the list at the moment, before we call the method, could be empty, or it may not be empty. It may have some data already. So, and the way you have to implement this method depends on the two different criteria. Okay, so let's start, let's say, with the easier one. Suppose the list is empty. So obviously, if the list is empty, this will be false. Not is empty will be false, because it's empty will be true. Okay, say if not is empty, do this, else do that. So in the case of empty, this is what we have presently. Uh, well, we have actually just like this. This is what we have. If the list is empty, this is what we have. Head is null, tail is null. There are no nodes at all. Okay, so if that is the case, what do we do? It says head becomes tail becomes new node. So again, this is assignment statements, actually two assignment statements, but they are put together in one statement. Now, assignment statements are always executed from right to left. So actually, the first thing that will be done is this. Then assign the result to that. And then assign the result of this to that. So we're going to show the explanation in the same order. What does new SSL node will do? What will it do? Exactly as I explained before, whenever you say new, you are saying create an object. So here an object is going to be created, an object of the SSL node. So of course that object will have two variables, info and next. Okay, and we are calling a constructor. Since we are providing only one value here, it means we are calling the middle constructor of the SSL node class. So what it will do is it will take this element and save it in the info, and it will save null in the next. Therefore, this is what will happen as a result of calling the constructor. Suppose element is 6. Suppose you call this method with 6. Then 6 will be stored in the info and null will be stored in the next. Okay. Next is the reference to that node will be assigned to tail. So tail is no longer going to be null. It will point to the new node. And then finally you say whatever is in tail to also be in head. What does that mean? It means head will also point to the new node. So actually the effect of this statement is shown here. So we start from an empty list where we have just head equal to null and tail equal to null to a list that now has one node. Now since this is the only node, it is both the first node and the last node, and therefore both head and tail will point to that a single node. Okay, so this is what our add head will do in case the list is empty. But what if the list is not empty? Suppose our list already has some nodes, 3 nodes as shown in here. A node containing 5, another one containing 8, another one containing 3. What will our add to head do if we give it 6, for example, as the element? Okay, so let's look at the statement. It says head becomes new SSL node element head. Okay, so the first thing is new. New means always create an object of the class. So the object of the class is created with the two variables, info and next. Second, and this is very important, a constructor is being called. The question is which of the constructors? Obviously, this is the last constructor. If you remember, first constructor takes no input. Second constructor takes only one element. And the third and last constructor takes 2 elements. So by providing 2 elements, when we call the constructor, we are actually calling the last constructor. So this element will be assigned to the info. So assuming it is 6, 6 will be stored here. Okay. 6 will be stored in the info. What about the next? We are saying save in here and in next whatever is in head. The question is, what is in head right now? In head right now, is the address of this node. So we are saying the next of our new node should be the address of this node, meaning let it point to this node. I should emphasize, gentlemen, that here, whenever you see an arrow from a head to a node, we don't mean the reference is to the 5. No, it's to the whole object. Okay, so head is pointing to the whole node, not just the variable 5. Okay, right. So head is pointing to this node, and we are saying put head in next. Okay, if you recall, that's what the constructor will do. Just to remind you, it's a bit far away, but I can still go back and show you. No, I think I passed it. No, I have not. Yeah, this is the last constructor. The second argument you give it is being saved in next. Okay, this variable next, which has this location. Okay, so we send head to be the value here. Therefore, next becomes head. Okay, and therefore, the content of our new node. Yeah, so this is basically what will happen. The next of our new node will point to head, just like will point to this first node or original first node. Okay, because we say put in next the value of head. Well, the value of head is the address of this node. Therefore, next will contain the address of that node. I hope this is clear. Good. So this is the end of executing the right-hand side. Now, after that, we are saying assign the result of that new node to head. Now, this is interesting because we are using head twice. First, we use its current value to initialize the next of the new node. And now we are saying save the address of the new node in head. Shabab, if you notice, this is simply like saying x equal to x plus 5. Okay, so you take the current value of x, add 5 to it, assuming the current value is 2. So 2 plus 5 will be 7. You are now saying save the 7 back to x. So x will now change to become 7. This is very similar to what is happening here. Okay, so after using the current value of head to initialize this next, the new will return to us the address of the new object. Now we are saying save the address of the new object into head. So head is going to change. It's no longer going to be pointing to this node. It's going to point to the new node. This is why you see the arrow here of head is coming to the new object. And if you observe, what we have done is we have successfully added a new node at the beginning of the list, which is the purpose of this method. The method is first to help us add a node at the beginning of the list. So we are saying if already there are nodes in the list, this is the result. A new node will be created. It next will point to the current first node. Okay, but head will change to point to the new node. Okay, because as we know, head is always referring to the first node in the list. So since we have added a new first node, head must point to that. Okay, of course, if the list is empty, then you're going to create the node, and both head and tail will point to it. So this is the idea of add to head. Let's move on to add to tail.